Państwu.
Good day.
W części trzeciej mówić będziemy o oddziaływaniu wzajemnym materii. Zanim jednak przejdziemy
In part 3, we'll talk about the interaction of matter. Before we get to mass or gravity, however, a few words of reminder. In the previous episode, I talked about the formation of matter. The new theory of light shows that matter is made up of 5 basic molecules: a positron, an electron, a small positron, a small electron, and a photon. It has also been calculated that the positron and electron contain over 12 million, and that the small positron and small electron contain over 8 million photons. They should look like a hedgehog curled up in a ball. These are molecules that make up both a proton and a neutron.
takie właśnie cząsteczki tworzą zarówno proton, jak i neutron. Aby zrozumieć mechanizmy wzajemnego oddziaływania materii, konieczne jest przeanalizowanie powierzchni protonu i neutronu. Na rysunku przedstawiono fragment powierzchni neutronu. Na całej powierzchni neutronu symetrycznie i naprzemiennie ułożone są pozytony i elektrony.
To understand the mechanisms of interaction of matter, it is necessary to analyze the surface of the proton and neutron. On the entire surface of the neutron, positrons and electrons are arranged symmetrically and alternately. Since the chains are terminated in both positrons and electrons with photonuses with electric charges at their ends, they must interact with photonuses circulating in space. Photonuses taken from space will form chains that will form outside the neutron. They cause its additional compression and are described in the drawing as lines of compressive forces.
Tych łańcuchów wychodzi na zewnątrz neutronu i tworzy linię sił pola grawitacyjnego. Jeżeli spojrzymy jeszcze raz na powierzchnię neutronu, to widzimy, że linie grawitacyjne wychodzą na
Only a very limited number of these chains go outside the neutron and form the lines of force of the gravitational field. If we look again at the surface of the neutron, we see that the gravitational lines alternate from the positron and the electron. This means that the directions of these lines of gravity should alternate in the drawings.
zawsze będzie
It also means that in gravitational interactions there will always be only the attraction of bodies, never repulsion.
nieco inaczej przedstawia się sprawa z protonem. W protonie występuje przewaga jednego pozytonu nad elektronami i z tego też powodu ma ładunek elektryczny +1. Na powierzchni protonu muszą zatem znaleźć się obok siebie 2 pozytony. Równowaga, jaka była w neutronie,
It is a bit different with the proton. The proton has an advantage of one positron over the electrons and therefore has an electric charge of +1.
2 pozytony.
2 positrons must therefore be placed next to each other on the surface of the proton. The equilibrium that was in the neutron here is disturbed. The figure shows a fragment of the proton surface selected so that 2 positrons appear next to each other. We can see that they exist over the entire surface between the positrons and the electrons, just like lines of compressive forces in neutrons. Only in the immediate vicinity between the 2 positrons are the lines of force. Compressive stresses turn into lines of force of the electrostatic field reaching very far beyond the proton. What additional functions such a window plays on the surface of the proton will be explained in the following sections, when discussing the movement of electrons within an atom. The description presented shows that the lines of force of a gravitational field always begin in the atomic nucleus and end in another atomic nucleus. Since any body is composed of atoms, there will be gravitational forces between these bodies. These forces will always attract the bodies to each other, never to repel.
Siły te będą zawsze powodować przyciąganie się ciał, nigdy zaś odpychanie. Oddziaływanie elektrostatyczne. oddziaływaniu tym dwa ciała posiadają ładunki elektrostatyczne i są oddalone od siebie.
Electrostatic interaction. In this interaction, two bodies have electrostatic charges and are spaced apart. This situation will be immediately reacted by photonuses and chains of photonuses orbiting in space and will align with the interaction of charges, creating lines of force of the electrostatic field. Depending on the sign of the charges, we will consider two cases. Case 1, two bodies have charges about opposite signs. In this situation, the bodies will attract each other and the ends of the photonus chains will close between the bodies. The interaction will be similar to gravity, only much stronger.
Przypadek drugi. Dwa ciała mają ładunki elektryczne o tych samych znakach. W tym przypadku sytuacja zmieni się radykalnie, ponieważ łańcuchy fotonusów wychodzące z obu tych ciał na swoich końcach będą miały takie same ładunki o takich samych znakach.
Case 2, two bodies have electric charges with the same signs. In this case, the situation will change radically because the chains of photonuses coming from both bodies at their ends will have the same signs and will repel each other. This will force the strings outwards so that they do not touch each other. Since the chains of photonuses have a certain stiffness, there will be more and more resistance to trying to bring these bodies closer together. The examples presented in the figures show that the photon chains in physics are currently represented as lines of electric field force.
Opis pola magnetycznego.
The description of the magnetic field was omitted because of its complete similarity to an electric field. The charges are replaced by the magnetic poles N and S.
Powstawanie pola grawitacyjnego wyjaśniono wcześniej, opisując powierzchnię protonu i neutronu. Na bazie tych
The
opisów
formation of the gravitational field was explained earlier by describing the surfaces of the proton and neutron. Based on these descriptions, let's explain the phenomenon of inertia. What is inertia? What does physics say on this subject? Inertia, a property of all material bodies with a resting mass greater than zero,
i na ciało.
consisting in the fact that in an inertial frame of reference, if the body is not affected by force or the acting force is balanced, it moves with a uniform motion or remains at rest.
A czym jest siła bezwładności? Ale siła. Siła bezwładności. Inaczej siła inercji, albo inaczej siła pozorna. Siła pojawiająca
What is the force of inertia? Inertia force, apparent force appearing in a non-inertial frame of reference, resulting from the acceleration of this system. The force of inertia is not an interaction with other bodies, as is the case, for example, in the force of classical understanding of gravity. In the current knowledge of physics, the force of inertia is described as an apparent force and as a force that does not interact with other bodies.
Sprawdźmy jak to zjawisko bezwładności wyjaśnia nowa teoria światła. Przypomnijmy sobie, że w neutronie czy protonie na powierzchni zewnętrznej znajdują się na przemianie.
Let's see how the phenomenon of inertia is explained by the new theory of light. Let us recall that in a neutron or a proton on the outer surface there are alternating positrons and electrons that end in photonuses. It has also been shown that only a very small part of them participate in the gravitational interactions. Let's draw such a surface and mark it with green color. We draw some photons into this surface. The tips of the photons will protrude above the surface. According to previous descriptions, the electrical signs of these photons will be alternating.
Gdybyśmy rozpatrywali siły grawitacji, należałoby do nich dołączyć łańcuchy fotonów. Ponieważ mamy rozpatrywać bezwładność, pominiemy te łańcuchy, gdyż utrudniałyby jasny opis zjawiska bezwładności.
If we were to consider the forces of gravity, chains of photons should be attached to them. Since we are to consider inertia, we will ignore these strings because they would hinder a clear description of the inertia phenomenon. Above, let's draw the body, M, in brown. Let us assume that the body, M, is mounted in a device that allows it to move freely without resistance parallel to the plane with the photons. According to the laws of gravity, lines of force of the gravitational field will form from the body, M, to the surface with photons. For the sake of clarity, let us draw only one such line consisting of photons.
Nadajmy takiemu obrazowi dynamikę. Ciało M natychmiast ustawi się tak, aby linia siły grawitacji była najkrótsza, bo siła grawitacji to spowoduje. Ciało M pozostanie w tej pozycji bez ruchu.
Let us make such an image dynamic. The body, M, will immediately position itself so that the line of force of gravity is the shortest, because the force of gravity will do so. The body, M, will remain motionless in that position. Let's follow what will happen if the force F is applied to the body, M, with direction as in the animation. If the force F is too small, the photon chain will tense and return to its previous position after the force ceases to act. A corresponding increase in the force F will break the photon chain and the body, M, will continue to move. Consider how far the M body will go.
Rozerwany łańcuch będzie jeszcze hamował ruch, chociaż coraz słabiej, aż do połowy odległości pomiędzy fotonusami o takim samym znaku, z którego został oderwany. Na rysunku ze znakiem plus. Po przekroczeniu połowy wskazanej odległości łańcuch będzie przyciągany do drugiego fotonusa.
The broken chain will still inhibit the movement. Although weaker and weaker up to half the distance between the photonuses with the same sign from which it was torn off in the figure with the plus sign. After exceeding the half of the indicated distance, the chain will be attracted to the second photon. The force breaking a chain of photons and the force attracting the next one will be the same. So the M body will move uniformly without the use of any force. To stop this movement, we must use the same force as the value with the opposite sense. The whole is shown in the animation. Now consider what causes rotational inertia. The gyroscopic phenomenon has been known for a very long time, but there is no physical explanation for this phenomenon. How this phenomenon explains NTS.
Wiemy, że grawitacja jest związana ściśle z obiektem. Jeżeli ciało zacznie wirować, to i linie sił grawitacyjnych pochodzące od tego obiektu też zaczną wirować. Musi to spowodować działanie sił odśrodkowych na...
We know that gravity is closely related to an object. If the body begins to spin, then the lines of gravity from that object begin to spin as well. It must cause it the action of centrifugal forces on the lines of force of the gravitational field, because we know that they are made of photons, and therefore of matter. If we do such an experiment in the gravitational field of the Earth, the lines of force of the gravitational field coming from the rotating body will diverge more and more as the rotation increases. So the theoretical basis of this body will also increase, which must result in increased stability. This is why it becomes more and more difficult to deflect the axis of rotation of this body. This property of a rotating body is called the gyroscopic effect. The gyroscopic phenomenon is shown in the animation. For the sake of clarity, only one line of gravity on both sides is shown.
Dla zachowania przejrzystości pokazano tylko po jednej linii sił grawitacyjnych z obu stron. Jest to jeden ze sposobów
This is one way to control gravity. Although of little use, it indicates that gravity can be controlled. A good knowledge of the phenomenon of gravity should contribute to finding in other ways. Modern physics interprets the force of inertia as an apparent force that does not result from interaction with other bodies. In light of the presented new light theory of this phenomenon, he is wrong. The presented interpretation in NTW shows that at least two bodies must act on each other by gravity in order to create a real, and not an apparent, force of inertia.
Przedstawiona interpretacja NTH pokazuje, że co najmniej
This is one way to control gravity. Although of little use, it indicates that gravity can be controlled. A good knowledge of the phenomenon of gravity should contribute to finding in other ways. Modern physics interprets the force of inertia as an apparent force that does not result from interaction with other bodies. In light of the presented new light theory of this phenomenon, he is wrong. The presented interpretation in NTW shows that at least two bodies must act on each other by gravity in order to create a real, and not an apparent, force of inertia.
z przedstawionej informacji wynika, że jeżeli dowolne ciało pozbawilibyśmy w sposób sztuczny sił grawitacyjnych, to ciało to zostanie również pozbawione bezwładności. A właściwie
The information presented shows that if we would artificially deprive any body of its gravitational forces, then the body would also be deprived of inertia, or rather inertial forces. This means that although the body retains its weight, the body will not obey most physical laws. In such a situation, it will be possible for the body to reach the speed of light, or even a multiple of that speed, using very little force. Theoretically, there is a way to decompose the force lines of a gravitational field, but it requires an appropriate technical background and considerable financial resources.
na tym zakończę dzisiejszy wykład na temat wzajemnych oddziaływań materii.
At this I end today's lecture on the interplay of matter. As the topic has not been exhausted, it will be continued in the next episode. Thank you for your attention and see the next episode.
Do zobaczenia.
See you soon.